Let us quickly have a look on content of presentation. Firstly, we will see the definition of acid and base, then Arrhenius theory, limitation of Arrhenius theory, Bronsted and Lowry's theory, then Levy's theory. Then next is the monograph of boric acid, hydrochloric acid, strong ammonium hydroxide, calcium hydroxide, sodium hydroxide, buffers, mechanism of buffer and role of buffer in pharmacy. Let's see the definition of acid. Acid are the substance which converts a blue litmus paper to red, having the pH less than 7. Acid usually has a sour taste when the acid is react with bases to form a salts and water. Example is hydrochloric acid. Then next is base. Base are the substance which convert a red litmus paper to blue, having the pH more than 7. Base usually has a bitter taste when the bases react with acid to form a salt and water. For example, sodium hydroxide. Then next is the Arrhenius theory. The concept of acid and base was first presented by the Arrhenius in 1884. It is also known as the Arrhenius theory of ionization and the electron dissociation theory. According to the Arrhenius theory, any acid or base on dissolution in water dissociates, forming ions and establishes an equilibrium between ionized and unionized molecule. According to the Arrhenius theory, acid is a substance which when dissolved in water it gives the H+. It means hydrogen ion is known as the acid. Example is hydrochloric acid. HCl it gives the H++ Cl- ion. Then next is the base. Base is a substance which when dissolved in water it gives the OH-. It means the hydroxyl ion is known as the base. Example is sodium hydroxide. NaOH it gives the Na++ OH- ion. Then next is the limitation of Arrhenius theory. The Arrhenius acid-base theory is most simple and convenient to explain. The reactions in aqueous solution has a number of limitations. The limitation of Arrhenius theory are: the definition of acid and base are only applicable for aqueous solution, not for the substances. Then the theory does not explain acidic and basic property of substance in non-aqueous solvents. Then next is the neutralization of acid and base in absence of solvent is not explained. In neutralization reaction, acid react with the base. It forms a salt and water. For example, hydrochloric acid react with the sodium hydroxide. According to the Arrhenius theory, neutralization as the process in which the hydrogen ion and hydroxyl ion combine to form an unionized molecule or water. The next limitation is the basic substance which do not contain a hydroxide ion is not explained by the theory. The next theory is Bronsted and Lowry's theory. According to this theory, acid is a substance which donate a proton ion in chemical reaction. Example is HCl, it gives a H++ Cl- ion. Then next is the base. Base is a substance which accept the proton ion in chemical reaction. Example is OH- plus H+, it gives the H2O molecule. Then next is the Levy's theory. According to the Levy's theory, acid is a substance or molecule or ion except the lone pair of electron in chemical reaction. Example is H+ plus NH3, it gives the NH4 ion. Then next is the base. It is a substance or molecule or ion donate the lone pair of electron in chemical reaction. Example is NH4, it gives the H+ plus NH3 ion. Then the monograph of boric acid. The molecular formula for the boric acid is H3BO3 and molecular weight is 61.83 gram per mole. The synonym for the boric acid is orthoboric acid. Next is the physical property. The first physical property is it is a white crystalline powder, and second is it is a odorless and tasteless. Next point is the chemical properties. First chemical property is when it is heated at 100 degrees Celsius. When the boric acid is heated at 100 degrees Celsius, it gives the metaboric acid plus water molecule. Then next is the when heated at 160 degrees Celsius. When the metaboric acid is heated at 160 degrees Celsius, it gives the tetraboric acid with the water molecule. Then third is when heated above at 160 degrees Celsius. When the tetraboric acid is heated above 160 degrees Celsius, it gives the boron trioxide with the water molecule. The next point is the assay. The boric acid is based upon acid-base type of titration. When the boric acid is dissolved in glycerin and directly titrated with the strong base of sodium hydroxide by using a phenolphthalein as an indicator. It gives the end point is colorless to light pink. Then next is the uses of boric acid. The boric acid is used in the preparation of buffer solution. Then it is also used to maintain the acidic pH in various topical preparations. Then next is it is used in ophthalmic solution. Boric acid is used in solutions, ointments, cream, dusting powders. Then boric acid is also used in solutions, are mainly used in eye and mouthwash for local anti-infective action. Next point is the storage. It is stored in well closed container and it is incompatible with the alkali, carbonate and hydroxide. Sometimes the glycerin are used in boric acid assay because of boric acid is a weak acid. It is a tribasic acid, so it cannot be easily titrated with the standard alkali, because so it can gives a accurate endpoint. So it mix with the glycerin or mannitol. It converts a from weak tribasic acid to the strong monobasic acid. Then it forms a glyceroboric acid complex and easily titrated with the standard alkali by using a phenolphthalein as an indicator, which shows an accurate endpoint. The next monograph is hydrochloric acid. The molecular formula for the hydrochloric acid is HCl and molecular weight is 36.46 gram per mole. The synonym is spirit of salt and muriatic acid. Next point is the preparation. It is prepared by the diluting concentrated HCl with the purified water. Ratio is 5:200 ml. Such contains an 10% of weight by weight of hydrochloric acid. Next point is the properties. It is nearly colorless, clear and foaming liquid. It possesses an pungent odor and it is soluble with water and alcohol. The next is it is a strong acid and attacks a metal, forming the hydrochlorides with the evolution of gas. The next point is the chemical property. It reacts with the sodium metal. It results in the formation of the sodium chloride with liberation of the hydrogen gas. Next point is the storage. It is stored in well closed container of glass or other inert material at the temperature not exceeding 30 degrees Celsius. Then next point is the uses. It is used as a pharmaceutical aid or an acidifying agent. Next is it is used in gastric acidifier when the level of hydrochloric acid in the gastric juice are low. The next use is it is used externally, used as a solvent, catalyst in bias pharmaceutical, and it is used as a acidifiers. The next point is the incompatibility. It is incompatible with the silver, mercury and lead and etc. Next monograph is the strong ammonium hydroxide. The molecular formula for strong ammonium hydroxide is NH4OH. Molecular weight is 35.5 gram per mole. Next is the synonym. Synonym is ammonia water, ammonium liquor. Next point is the preparation. It is prepared by passing the ammonia gas into the cool water until the ammonia water is saturated. It forms an ammonia or strong ammonium hydroxide. Next point is the properties. First is color is colorless, odor is strong, pungent, taste is characteristic, solubility is it is soluble in water and melting point is 57.5 degrees Celsius and density is 0.91 gram per centimeter cube. Next is the uses. Its salt are used as an antacid, counter irritant and stimulant. Next use is it is used in the various common laboratory reagent. Then it is used as a additive to maintain the correct level of acidity in food items. Then it is also used in preparation of soaps, detergents, creams and pharmaceuticals, then inks, etc. Next point is the storage. It is stored in well closed container. It is usually kept in amber color bottle with the dropper. Next point is the incompatibility. It is incompatible with the acids, hypochlorites, then halogens, sodium hydroxide. The next monograph is the calcium hydroxide. The molecular formula for calcium hydroxide is CaOH 2 times. Then molecular weight is a 74.09 gram per mole. Synonym is slack lime and lime water. Next is the preparation. The calcium oxide is react with the water molecule. It forms an calcium hydroxide. The next is the physical properties. First is colorless crystal or white powder. Then the density is 2.21 gram per centimeter cube and melting point is 580 degrees Celsius. Next is the chemical property. When the lime or calcium hydroxide is react with carbon dioxide, it forms an calcium carbonate with the water molecule. Next point is the uses. First is it is internally used as an antacid, then it is used as a source of calcium, it is also used as a pesticide, it is also used as a astringent, and it is also used in sunscreen lotion and oily preparation to forming calcium soaps of fatty acids. Next is the storage. It is stored in airtight container in cool and well ventilated place, and it is incompatible with the strong acid. Next monograph is the sodium hydroxide. The molecular formula for sodium hydroxide is NaOH and molecular weight is 40 gram per mole. Synonym is the caustic soda. Next point is its preparation. It is prepared by the soda lime process. In this method, the sodium carbonate is heated with the calcium hydroxide. It forms an calcium carbonate and the sodium hydroxide. Then the physical properties. First is it is a white mass, odor is odorless, and it is soluble in water and freely soluble in alcohol and glycerin with the evolution of the carbon dioxide. The next is the uses. It is used as a pharmaceutical aid. It is also used in common laboratory reagent, and it is also used in the preparation of soaps. Next is the storage. It is stored in tight closed container as it absorbs the moisture and carbon dioxide. Next point is the incompatibility. It is incompatible with acids, organic halogen compounds, and especially trichloroethylene may causes an violent reaction. Next point is the buffer. The definition of buffer is: buffer are the solution or system that resist a sudden change in pH value on the addition of small amount of acid or base is called as the buffer. A buffer solution consists of mixture of weak acid and its salt, or weak base and its salt. To such solution, when the small amount of acid or alkali is added, no significant change in the pH result. The buffer solution are prepared either by mixing a weak acid with its salt or weak base with its salt. The next point is the type of buffer. There are mainly three types of buffer. First is acidic buffer, second is basic buffer, and third is neutral buffer. Let's see one by one. First is the acidic buffer. A buffer which contains a weak acid and its salt of strong base is called as acidic buffer. Example is acetic acid. Then second one is basic buffer. A buffer which contains a weak base and its salt of strong acid is called as the basic buffer. Example is ammonium acetate. Third one is neutral buffer. It is a compound of salts of weak acid and weak base is called as a neutral buffer. Example is ammonium acetate. Then next point is the mechanism of buffer. First is the acidic buffer system. The acidic buffer system contains an acetic acid and sodium acetate. The acetic acid is weak acid and sodium acetate is a strong base. In acidic buffer solution, if a small amount of hydrochloric acid is added, H plus ion combines with the acetate ion and forms an acetic acid, resulting in no change in the pH. Then next is the in acidic buffer solution, if a small amount of NaOH is added, hydroxide ion is combines with the acetic acid, it forms an acetate ion with the water molecule. Then next is the basic buffer system. Basic buffer system contains an ammonium hydroxide, ammonia, and ammonium chloride. The ammonium hydroxide is the weak base and ammonium chloride is the strong acid. In basic buffer solution, if a small amount of hydrochloric acid is added, the H plus ion combined with the ammonium hydroxide, it forms the ammonium ion with the water molecule. Then in basic buffer solution, if a small amount of NaOH is added, the hydroxide ion combines with the ammonium ion, it forms an ammonium hydroxide. Then next point is the role of buffer in pharmacy. First is specific compound are soluble in specific medium of suitable pH, the required pH adjusted by the buffer. Then second one is color of synthetic compound like phenolphthalein is also pH dependent. And third is the stability of various compounds depend upon the pH. For example, ascorbic acid and penicillin are unstable in alkaline pH. Then fourth is internal and external use of preparation with the appropriate pH, otherwise there will be the possibilities of the tissue damage. Thank you.